Hey everyone, welcome to InsightsByRish. In today's video, I am going to explain you about the three most popular and highly used train test split methods, and they are Holdout Method, Stratification Method, and the K-fold cross-validation method. Now, there are various techniques in machine learning to divide your data set into the training set and testing set, but these three are the most used and are very popular methods. So as you know, in machine learning, before building our model, we divide our data set into two parts, that is the training set and testing set. We train our model using the training set, which means the model learns all the data from the training set, and then we evaluate our model's performance using the testing set. So the first method that we'll study about is the holdout method. As you can see, I have imported few libraries here, that is the pandas and cbun. Then I have loaded the iris dataset from the cbun library. Then, so let's run that. So as you can see, this is our dataset, and we are going to study various train test split techniques using the iris dataset. So as you can see, the first four columns are our input features and the last species column is our target feature. So what I have done here, I have basically divided the dataset into the input data frame and the target feature. X is a variable of type data frame which will hold all the columns except for the column species, that is all the input features. So let me display that. As you can see, these are all the input features, and Y variable will hold the species column. Now let us check the dimension of the dataset. It consists of 150 rows and 5 columns. Fine. Now we will actually do the train test split using the holdout method. So let us import train test split module from sklearn. So from sklearn.model selection, we will import train test split here. Then we will say xtrain, xtest, ytrain and ytest is equal to train test split. Here we will pass our input data frame, which is x, then our target feature, which is y, and then the most important attribute, which is test size. Now what will be the test size? For this test size attribute, as you can see in this particular picture, we have to divide our dataset into two parts, training set and testing set. So let us, for an example, consider a dataset of 100 rows. Let us assume that our dataset consists of 100 rows. So when you give the value of test size as 0.2, which means you are dividing your dataset with 80% of data in the training set and 20% of the data in the testing set. As you can see in the first diagram, from the 100 rows, the 80 rows are in the training set and 20 rows are in the testing set. Now when you give the value of test size as 0.3, then you divide your data set into 70% of data in the training set and 30% of the data in the testing set. As you can see, out of 100 rows, 70 rows are in the training set and 30 rows are in the testing set. And when you give the test size as 0.5, then basically you are dividing your data set into two equal half parts. That is 50 rows in the training set and 50 rows in the testing set. But this is not an ideal condition. You should never give your test size where you are having equal number of rows in the training and testing set. Due to this, what happens, your model doesn't learn much and your model's performance decreases. So one thing that you should keep in mind while giving the value for test size is your training set should always have more number of rows as compared to your testing set. So test size is equal to 0.5 is not an ideal condition. Except for that, you can give any condition you want. Fine. So this is what you have to do. Let us assume now as test size is equal to 0.2, which means 80% rows in the training set and 20% rows in the testing set. And then random state is equal to 42, which basically means that whenever we will rerun this particular cell, same rows will be included in the training and testing set. If you don't give this attribute of random state is equal to 42, then what will happen is basically when we rerun this particular cell and we don't have this attribute, then every time we will have different rows in our training and testing set. And that's why this attribute is necessary. You can give any value for random state, but the standard value is 42. Let's run that and let us check the shape of training and testing set now. So we will say xtrain.shape and xtest.shape. Let's run that, and as you can see, our data frame was of 150 rows, and out of that 120 rows are in the training set and 30 rows are in the testing set. This is because we have given the test size as 0.2. If you change the value of test size from 0.2 to 0.3, then you can see now out of 150 rows, 105 rows are in the training set and 45 rows are in the testing set. So you can give any value here. If you give 0.5, which is not an ideal condition, you can see your data set is equally divided into two half parts, 75 rows in the training set and 75% rows in the testing set. So this is the basic holdout method that most of us perform. The second method here is the stratification method. So let me run all of this. Now there is a slight difference between the stratification method and the holdout method. Everything else is same, but there is a very slight difference, and the difference is when you consider the first holdout method. Let me rerun the cells. When you consider this, so you have three species into this dataset: Setosa, Virginica and versicolor for iris dataset. So as you can see, I will check the value counts from the original data frame. So value counts, and as you can see, we have equal number of samples for all the three categories. So out of 150 rows, we have 50 rows for Setosa, 50 for versicolor and 50 for Virginica. But when we check the value counts for our training and testing set, so let me write here dot value counts. Let's run this. As you can see, initially in our data frame, we have equal number of samples for all the three categories. But in our training set, we are having different number of samples for the categories. Like versicolor 27, Virginica 27, but the Setosa are only 21. And same goes for testing set as well. You can check test dot value counts. 29 for Setosa, 23 for versicolor and 23 for Virginica. As you can see, in your training and testing set, you don't have equal number of sample for all the three categories, and that's where you use the stratification method. So let us perform the stratification here. We will again import the model selection. So let me rerun this cells. So I will say from sklearn dot model selection, I will import the train test split here. Then xtrain and xtest, ytrain and ytest is equal to train test split. Everything else basically remains same. So again we will pass our input data frame and target feature. Then the test size, you can give any test size as you want. So let us keep it 0.2. Then random state is equal to 42. And here you will give an important parameter, which is stratify. So this is the stratify parameter. Here you have to give the value for which you have to perform stratification. As you know, all the categories of Setosa, versicolor and Virginica are present in y variable, and hence we will pass that y variable here for stratify. Let's run that. And now let us check the value counts from ytrain. So ytrain dot value counts. Let's run that. And now you can see we have equal number of samples for all the three categories in our training set, and it will be same for testing set as well. So let me say ytest dot value counts. Let's run that. And as you can see, now we have equal number of samples for our training set and our testing set. Initially when we performed the previous method of holdout, let me change this test size to 0.2 here. So there you can see that we had different value counts for training set and testing set. Like in your training set, you didn't had equal number of samples for all the three categories, and same for your testing set, you didn't had the same number of samples for the test set as well. So when you perform the stratification method, now you have same number of samples for all the three categories in the training and testing set. So this is when stratification method is used, when you want equal number of samples of all the categories to be included in the training set and the testing set respectively. So this was the second method. And the third and the last method is k-fold cross validation. Again, I have imported the iris dataset here, as you can see. Now we will try to understand about the k-fold cross validation method first. So what this method does here, take the look at this picture. So first you have your entire data set. So your figure 1 is your original entire data set, and here you have a parameter called as k. You have to give the value of this parameter k. Let's consider that we have given the value of k as 3. So basically, as you have given the value of k is equal to 3, it will divide your entire data set into 3 equal parts, or you can say 3 subfolds. So your k1, k2, k3 are the 3 folds of your data set. So as you can see in the figure 2, it had divided your data set into 3 parts, K1, K2 and K3, and it will also perform the 3 iterations. So in the iteration 1, it will consider the first 2 folds, that is K1 fold and K2 fold, as the training set, and the last K3 fold as the testing set. Then it will build a model using this training and testing set, and it will evaluate that. Let us consider that the accuracy of the model 1, considering the first 2 folds as training set and the last fold as testing set, is A1. Then in the second iteration, it will consider the next 2 folds as the training set, like the K2 and K3 fold as the training set, and the first, that is the K1 fold, as the testing set. It will again build the model using this particular training and testing set, and it will evaluate the model 2 with an accuracy of A2. And in the last and the third iteration, it will consider the first and the last fold, that is the K1 and K3 fold, as the training set, and the second fold, that is the K2 fold, as the testing set. It will again build a model using this particular training and testing set, and it will evaluate it with an accuracy of A3. Then in the next step, what it will do is, it will take an average of all these accuracies. So A1 is the accuracy of model 1, A2 is the accuracy of model 2, and A3 is the accuracy of model 3. It will take an average of all these 3 accuracies, and that will be your final accuracy of the model using the K fold. So this is because, like, we divided our data set into the 3 parts and we performed 3 iterations. This is because we have given the value of K is equal to 3. You can give any value here. If you give K is equal to 5, then it will divide your data set into 5 folds, and then it will perform 5 iterations with the same technique, and then it will take an average of all those 5 models. That will be your final accuracy. So this is how K-fold cross-validation works. So we will go back to the code and we will try to write the code here. So what you have to do here, we will say from sklearn.model selection, we will import stratified K-fold here. Let's run that. And then here you will say folds. Here you have to give the value of how many folds you want. So let's say folds is equal to stratified fold. And here we will say that we have to split our data set into 3 folds. That is what we have seen in this particular picture. We are going to divide our data set into 3 folds. Let's run that. And here we have to manually write the code for train test split. So let us say for train underscore index, and then test underscore index. These are just the variable names. You can give it any name. In folds dot split input, that is your X, and target, that is your Y. Fine. So this is your simple for loop. Now inside this for loop, what you will do basically is, you will say xtrain, xtest, then ytrain and ytest is equal to input, and your input is your X, and hence it will be X dot iloc, that is the location, from train index, comma, next X dot iloc, let me write on the same line, X dot iloc test index, then Y dot iloc, that is the location, again train underscore index, and Y dot ilocation test index. Fine. So this is how you will write the code. So basically what we are doing here, we are dividing our data into the training and testing set. As you can see, these parameters xtrain, xtest, ytrain and ytest are same like we have in our train test split, as you can see, but we don't have this inbuilt module here. We are writing the code manually. So the xtrain will have this value, xtest will have this value, then ytrain will have this value, and your ytest will have this value. And let's run that. It's actually C. Fine. So this is how you perform. And now let us check the shape. So xtrain dot shape and xtest dot shape. Let's run that. And as you can see, you have 100 rows in your training set and 50 rows in your testing set. This is how you perform. Now, stratified k-fold is mostly performed when you have many rows in your dataset and you want the best accuracy there. It's not generally preferred when you have a small dataset. When you have a small dataset, in that case, you either go for the holdout method or for the stratification method. But when you have a dataset with lot of rows, then in that case you prefer the k-fold cross-validation method. So these are the three most popular and highly used train test split techniques. That's it for the video. Thanks for watching.